Here we are for ELF Weather and Water Center 2. Brought to you by Emmy.
Hello, Center 2. And you got to know that this one has part experiment and part craft with it. And so it's called Swirling Masses and Cotton Ball Clouds. The swirling masses is going to be used to demonstrate how convection currents cause thunderstorms to form. And then the cotton ball one, we will make a craft so that the kids can remember the names and types of clouds and maybe hopefully be able to identify them at home. If you're the one that takes Center 2, at home you need to make green or blue ice cubes. And I suggest making them in a cupcake tin because then you'll have really nice big ice cubes. I made these this morning. It took, I would say, I'm thinking less than 5 hours and they were ready. So, and after I filled them with water, put food coloring in there, I did 2 colors just to demonstrate. You could just pick, you don't have to do 2 colors. Then at school, as you're getting set up, you're gonna need to fill a carafe that we will have in the bins for you up with water and heat it up. And because that's key. There we go.
Oh. Well, it's not coming on. Oh, whoopsie. That light should be on. Ah, there we go. Jiggle.
Yay.
Pardon me.
And then in addition, you're going to need to fill this tank up with lukewarm water, and you're going to need to actually refill this for every rotation. So, and I suggest that you do that. In the outline it talks about you could have the kids do it, but I suggest that if you do it with the kids or however you do it, that you do it at the beginning before you start talking about everything so that it's able to just sit there and rest while you then briefly discuss that there are different types of clouds. And you could refer them back to the puppet show where they learned about the 3 different kinds of clouds. And then kind of move in, you can get out these cards, these pictures, that are all different kinds of clouds. This one, for instance, is a cirrus, altostratus, and stratocumulus. Lots of big names. The fact that there are cirrus clouds in here, that's one of the main ones you'll talk about. And there's all different examples and a cheat sheet.
We love a key. We have a key. Yay!
So this one is another altostratus. This is cumulus, and so on and so forth. So you're going to have them then focus on, well, what kind of clouds, what does a cloud look like that makes a thunderstorm? And hopefully they start to describe a cloud that looks like this, a thunderhead, or a cumulonimbus cloud. And there's also another really great illustration of different cloud types here as well. The cumulonimbus, those can reach 75,000 feet high. They're the ones, if you've ever been in an airplane, that you can see popping up. So, all these great charts and illustrations are in the bin. So, go through that and then review the basic properties of air. The fact that air takes up space, and ask the kids, do you think air is all the same temperature? Hopefully they'll say no, that there's cold air and there's warm air, even just from the basic winter-summer thing. And then you might talk about what causes weather, and it's the movement of air masses. So then, before you start your experiment here, pose these 3 questions to them. What's heavier, warm or cold air? Which holds more water vapor, warm or cold air? And what do you think is going to happen when a warm air mass and a cold air mass come together? Because that's what we're going to use this water to demonstrate, is warm and cold air masses coming together. So, we have our hot water.
Our hot water's hot.
Ice cubes. The rectangular tank is 2/3 full of lukewarm water, and you're going to ask a student to gently place 2 ice cubes in tank of water. And hopefully they'll stay together on the same side. Then, you, the adult, are going to fill the cup with hot water. The kids should not be filling and using the hot water. And then before you put the hot water in the tank, we're going to color it as well with about 4 drops or so.
Yeah, good luck.
Or a little pour. Whoops! Or a lot of pour of some red food coloring. So then we're going to slowly
Okay.
Pour this in the tank on the opposite end. Let's see. On the opposite end of the cold.
So the red is representing hot water, hot air moving through.
So you're going to ask the students what's happening, and it's a good idea to put a piece of white paper or even the white lid from the bin behind so that you can actually see, and it's a good idea to get down at eye level and see. So again, there's some more questions you can pose, and the kids can be talking about what they're seeing happen. And so where does the cold blue water go? It, hopefully you can see.
It's falling, it's going down.
Yeah. And what happens to the warmer red water? It was able kind of to disperse pretty quickly. And it is the warm water is rising. If you can see, like, it's mostly at the top. Although it's being where the cold water is, it's pushing it down. And so then if you imagine that the water represents warm and cold air masses coming together, and you go back to the questions you talked about earlier, you can ask, well, what's heavier, warm or cold air? And the answer should be that since the red is trying to stay on the top and the blue is sinking, that the warm air is lighter and the cold air is heavier. And then you can also discuss what's happening now that these warm air masses and cold air masses are coming together. Well, the cold is pushing the warm back down. The warm is holding the water vapor and it's bringing it back down to the earth if it was a thunderstorm, for instance.
Very cool. You can see it in real life. It's kind of hard to represent on the video, but it definitely swirled and it's circling, and you can see, and if you think of the things as clouds, the different colors as clouds, the air masses, it's kind of cool to see that way.
Yeah, I know. And then in the outline, there's a really good explanation that I will let you guys read through on your own. That basically explains what you're seeing and the process of convection currents.
Cool.
So that could easily take up your whole time. But if it doesn't, and or if you move through it fast, then your next part is going back and reviewing the different kinds of clouds that you probably just briefly went through at the beginning of this demonstration: cumulus, cirrus, and layered. And in your outline, it gives definitions of all of those. And then you'll have the students in the bin will be cotton balls and their own blue paper, which you divide into fourths, and then they can make an example of each of those, and then they can choose to make a favorite cloud or combine 2 of these kinds of clouds together like there were in those pictures and make a weather event on paper.
And they can even name their own cloud.
Yes.
The Emilicious Lucius Saracenerfermerner.
Yeah.
Easy for me to
And,
say.
of course, a few books, which I'm sure you will have zero time for. But there you have it. They have good pictures of some weather clouds.
Yeah, very cool.
So,
Okay, so that wraps up Elf Center 2 for Weather and Water. Thank you. Oh, mitchellelf@gmail.com.